Every year, exploration companies collect massive volumes of geological and geophysical data. From satellite imagery and field mapping, to geophysical surveys, to drilling and laboratory analysis. Terabytes of information, generated across multiple disciplines, all aiming to answer one critical question. Where is the mineral deposit, and how valuable is it? Yet, despite all this data, many exploration projects still fail. Not because there is a lack of information, but because the data remains fragmented. Geological maps, geophysical surveys, drilling results, each analyzed separately, instead of being integrated into one coherent exploration model. This program teaches the integrated workflow used by modern exploration teams. A systematic approach that combines geological interpretation and 3D geological modeling techniques, geophysical analysis, remote sensing technologies, artificial intelligence and machine learning technologies, geophysical borehole logging analysis technologies, geostatistical techniques, and drilling data, all into one unified exploration model, giving you the power to unlock mineral potential like never before. The future of mineral exploration belongs to those who integrate. Data alone is noisy. Integration creates discovery. From satellite pixels to subsurface signals to 3D resource models to bankable decisions. Welcome to the Integrated Modular Training in Mineral Resource Estimation. Pick the modules you need. Master the ones that define your career. From raw geological and geophysical data to AI-driven 3D resource models built on real industry workflows. Exploration does not fail because of lack of data. It fails because of fragmented interpretation. Magnetic anomaly without structural control is speculation. Resistivity anomaly without geological context is ambiguity. Remote sensing without ground validation creates false targets. AI without geoscience knowledge is statistical illusion. Precision in exploration requires integration. The real power lies in integration. That is why this training is modular, flexible, and workflow-driven. Module 1, GIS for Geoscientists. Global Mapper and QGIS. Every exploration decision begins with spatial control. GIS is not just mapping. It is the backbone of spatial decision-making in exploration. You will structure exploration databases professionally. Extract structural trends from DEMs. Rank targets using multi-layer spatial models. Build exploration intelligence maps. Without strong GIS foundations, data becomes fragmented. Targets become subjective. And investment decisions become risky. GIS transforms scattered datasets into strategic exploration intelligence. Without GIS, exploration becomes guesswork. Module 2, 3D Geological Modeling. Software used, Leapfrog Geo. Mineral deposits are not flat. They are structural, folded, fault-controlled systems. A 2D interpretation can be dangerously misleading. You will model lithology, fault, veins, folds and intrusion networks. Integrate drilling and geophysics. Build deformation-controlled geological frameworks that represent subsurface reality. Interpret structural complexity. Validate and quality control your models. Prepare outputs ready for reporting or resource estimation. Generate volumetric estimations. Reduce structural uncertainty. Reduce modeling errors. Improve geological consistency. Deliver higher confidence models. Support better exploration decisions. 2D interpretation hides risk. 3D modeling exposes reality. Without 3D modeling, or continuity assumptions become speculative. 3D modeling reduces geological uncertainty and increases investor confidence. Module 3, Remote Sensing. Software used, QGIS and ERDAS imagine. Before drilling. Before geophysics. There is satellite intelligence. Satellite imagery is often the first exploration filter. You will detect hydrothermal alteration halos. Use PCA and band ratios for mineral mapping. Identify regional structural corridors. But remember, alteration is not or. Imagery highlights possibility, not proof. Remote sensing alone cannot confirm mineralization. It highlights potential zones, not ore bodies. It must be validated by geophysics and geochemistry. Module 4, Advanced Geophysics. GemLink, Geosoft, Prozis RES2DINV, RES3DINV, EMA Vista Reflex 2D. Geophysics is where exploration becomes quantitative. You will master magnetic techniques. Detect structural trends, intrusions and alteration halos. Critical for mapping concealed lithology. But magnetics cannot define or grade. Gravity techniques. Identify density contrasts and deep intrusive bodies. Essential for regional scale targeting, but low resolution for shallow targets. Electrical resistivity and induced polarization. Detect chargeability and conductivity anomalies. Powerful for sulfide mineralization, but affected by groundwater and clay. Electromagnetic techniques. High sensitivity to conductive ore bodies. Excellent for VMS and massive sulfides, but sensitive to cultural noise and ambiguity. Radiometric techniques. Map potassium, thorium, uranium signatures. Helpful in alteration mapping, but surface limited and weathering sensitive.